Hey folks, how we doing? Hopefully, weekend was good for you. Hopefully you got some rest and were able to catch up on other stuff outside of school and everything like that. Today, Monday, day 5 for us in the physics world. Um, Remember, we got a quiz tomorrow, and then we also have a test on Friday. So that's a couple days looking forward down the road for us. Okay. Um, so what you're going to see today is that we're talking about delta V and acceleration. Your quiz topics for tomorrow. You're going to have some velocity and speed setup and also calculations. What the setup means is that you're going to have to match up what part of the problem goes where. Meaning, if we give you a velocity and a distance, you match those two up. You then put the question mark by the time. Calculations, we're just going to run straight numbers at you, or not straight numbers at you. We'll give you answers, multiple choice answers with the numbers in them. You just have to pick the correct one. Metric conversions will give you, like a kilometers and ask you for a meters or something like that, and where you have to convert using King Henry stuff. Length, mass, and or time conversion, we'll give you inches to centimeters, kilograms to pounds, seconds to hours, stuff like that. Okay. It's going to be somewhere between probably about 4 and 7 questions for us. Just depends on what we want to put on there, how many we want you to take through. You'll have about 25 minutes to do that. The hope is that you only need about 11 maybe tops. Okay. All right. Let's get it started then. All right. Average acceleration for us. When we talk about average acceleration, we just talk about average acceleration in general. Average acceleration for us is classified as speeding up. You start at a stop sign, push on the go faster pedal or the gas pedal, sorry, and you start to speed up. Whether that's up to 30 miles an hour, 45 miles an hour, 70 miles an hour, whatever that may be. But speeding up is average acceleration for us. Okay. Slowing down. So if you come to that stop sign, that red light, all of a sudden you drive into the back end of traffic, running down the street. That's also acceleration for us. Now, granted, we call that one maybe deceleration or negative acceleration, but it's still for us is that it's that same concept when we look at acceleration as far as our formula and everything like that is concerned. The third one, I don't want you to write this one down yet because for us this isn't necessarily important now, but it is changing direction. Once we start talking angular, January, February time of the year, then changing direction will become another acceleration for us. So for us, we're thinking just 1D motion. So we're thinking from left to right, just speeding up, right? Or we're thinking slowing down. Or we're thinking we, drop an object off of the building, speed up, right? Stuff like that. So, all right. Average acceleration is labeled as a bar for us. So what we're saying is that when you take off from that stop sign, what you see is you see a consistent acceleration, meaning that you increase, say, 3 miles per hour every second. All right. So you're going 3, you're going 6, you're going 9, you're going 12, you're 15, 18, 21, 20, so on and so forth, all the way up until you hit your speed that you want to go to. That's what we look at for average acceleration. We're not looking for a fluctuation in it, so to speak. Now, is average acceleration super realistic? Probably not a whole bunch, but yet at the same point for us, it is something that we can look for. Okay. Formula for us: average acceleration equals delta V over t. Now, please be aware, acceleration, everything like that, is not on the quiz tomorrow. That'll be for the test on Friday. Okay. So our acceleration, as you can see here, because that's delta V over t. Delta V is going to be meters per second, miles per hour. Delta T is going to be, seconds, minutes, hours, stuff like that. So our average acceleration can be meters per second. It can be miles per hour per second. It can be kilometers per hour per second. It can be meters per second per second. So we can get a couple different variations there as far as labels are concerned for us. All right. Delta V on top, the way that we find that is that's going to be final minus initial. Now, when we say it goes from 0 to 60, the 0 is the initial, the 60 is the final. If you've ever seen the 100 back to 0 kind of race, What that is that's where you start at 100 miles an hour, and then you see how fast you can stop and see how that stopping distance works for you if your final velocity is 0. Okay. Change in time, usually we set a 0 mark. So our 0 mark is usually when you start at that stop sign, and then how much ever time it takes for you to reach kind of your final velocity that you want to get to. So if we're all of a sudden going 0 to 60 in 6 seconds, well, then our delta t is going to be about 6 seconds. Okay, stuff like that. So then we ask the question: in order to go faster, our delta v would have to be what? Positive, right? How do we get it to be positive? Well, in that case, our final velocity has to be higher than our initial velocity. So we're accelerating, we're going faster by going 20 miles per hour to 30 miles per hour. That would give us a faster acceleration. We would have to speed up to get to that point. All right. Slower now means that our initial velocity has to be higher. So we're starting at 30, pressing the brake, or just taking our foot off the gas and going down to 20 miles an hour. So in that case, it is possible for us to have a negative v. Now, that's a little unnerving for some people just because we always think that that change should be positive, but if we're actually slowing down, we need it to be actually negative for that. Okay? So hopefully that makes a little bit of sense on how we can get that delta v to be a little bit different throughout the process here. Okay? Car speeds up from 20 meters per second to 30 meters per second. How much did it speed up? Well, for us, this is either 10 or it's a negative 10. If we see the initial is 20 and the final is 30, then it's going to be 30 minus 20. This thing should be 10 meters per second. All right? Then we say, okay, if this happens over 5 seconds, what's the average acceleration if this happens over 5 seconds? Well, if our change in velocity is 10 meters per second, the time it takes for this speeding up to happen takes place over 5 seconds. So that means that our velocity is going to be that 10, our time is going to be that 5. We see it's going to be 2 meters per second per second. Now, if you really wanted to, you could call that meters per second squared. Either one, absolutely going to be fine for us here. Okay. All right. So pause video for a second here. If you want to get a hold of a group mate, a partner, a lab, somebody, and see if you can run these 3 problems here. All right. I know I gave answers on the bottom, but just verify those and see that those answers are technically correct. Okay. Take some time now. Run these through in notes for yourself so that you can have them in case we run into problems that are similar to this on a quiz. Okay. So go ahead, pause it for 1 minute here, and then run through them. All right. All right. So hopefully you took some time, did these, all that good stuff. All right. Number 1. So Kid Dynamite drives his 1962 Ferrari California at 10 meters per second, then speeds up to 31 meters per second. It takes him 7 seconds to do this. What is the average velocity of this? Well, what we see here is we see that we have an initial velocity, right, of 10 meters per second, because that is the first one we see, right? He then speeds up to 31 meters per second. So that's why that's our final. All right. How long does it take him to do that? 7 seconds. Again, contextual clues tell us he starts at 10, he speeds up to 31. All right. So we want to find the average acceleration here at the end. Okay. So we plug our numbers in. So we go 31 minus 10 over 7. 31 minus 10 is 21. 21 divided by 7 gives us 3 meters per second or 3 meters per second squared. Okay. Now here again, because we say he starts at 10 meters per second, that's our initial. Because he speeds up to 31 meters per second, that's our final for us. Okay. All right. Next one. If Kid Dynamite continued accelerating at this rate, how much time would it take him to speed up 31 meters per second to 40 meters per second? So here again, we see our contextual clues. He starts at 31, he gets up to 40. Initial is 31, right? He's getting up to 40, that's going to be our final there. Now, if he continues accelerating at the same rate, guess what that means? Our acceleration is the same, all right? Mathematically, This one's tough, right? Because we're solving for an unknown on the bottom. So the way that we want to do this, we want to put that one over 1. We're going to take 1 times whatever this is. So 40 minus 31, that's going to be 9, right? And then we're going to go ahead and we are going to divide by that. So it should be 9 divided by 3, as you see here. The time it takes them to do that should be 3 seconds. All right? I'm going to encourage you, if you're solving for t in this one, put it over 1. It'll make your life a little algebraically more easy, so to speak. Okay? All right, last one. Famous jet pilot Meter Paran flies his F-22 fighter jet at a constant 350 meters per second, just above the speed of sound, for 52 minutes and 51.43 seconds. How far does he travel in this time? So what we see is he's traveling at a constant 350, right? So that's going to be my constant right here, is going to be that 350. Now, here's the tricky part, right? He goes 52 minutes and 51.43 seconds. Because this velocity is written in meters per second, we have to change that minutes into seconds. The way we do that, multiply it by 60, right? When we multiply that one by 60, we get, what, 3120, right? 3,120 seconds. So what we end up seeing here is this is actually represented in our seconds. So once we see that, we know our average velocity right here, right? We know our time. We're trying to find delta D, or the change in distance, right? So these two, put the time on the bottom. We should end up seeing, we're going to multiply these two together. We'll make that happen. So what we end up with is he's going to travel about 1,110,000 meters in that 52 minutes if he's traveling just above Mach 1 or just above the speed of sound. All right. If you want to, you can take a run at Section 2 homework. If you haven't done Section 1 or Section 3, then I would suggest that for tomorrow's quiz, you definitely do take a look at those, just so you can feel confident with them and feel comfortable doing those problems yourself. Okay? With that being said, have an awesome day, and we'll look forward to talking to you on Tuesday morning. Okay? Talk to you then. See ya.